for introducing me. Uh, Myself, Harun Akhtar Qureshi. I am the current PhD student in Parthenope University and remote sensing, electromagnetic and remote sensing lab. Well, the topic of my presentation is a sea wind field over the Gulf of Naples from SAR Imagery. Uh, just a second.
Arun, I think you can put it full screen. Okay, now it's fine.
Okay. Well, the overview of my presentation is a brief introduction, including results, and in the end, the conclusion. Well, the massive revenue can be produced from the ocean world. So, accurate and updated large-scale wind surface is very important from some applications like weather forecasting, wind field energy, CS monitoring, tourism, etc. So that's why we need to analyze the wind field, especially near to the coastal area, in large scale. So for this reason, there are major sources to get the information about the wind field on a local scale, like automatic weather stations, on-ship sensors or buoys, or to get the wind field on a large scale. Mostly the remote sensing sensors are used, like microwave spectrometer or microwave synthetic aperture radar like Sentinel-1 or radars are 1 and 2. No doubt, we get the wind field information on a large scale using the microwave spectrometer because of its characteristic of high revisit time, independent of weather conditions and independent of light. So uh, in this slide, we have to comparison between the spectrometer wind field versus the SAR wind speed. And we can see that the wind field can be retrieved, we can get the data from this using the spectrometer. But why we need to shift from the spectrometer to the SAR? Because the worst resolution of the spectrometer up to 25 kilometer, so near to the coastal area, we cannot get the wind field on a finer scale due to the contamination of land. So that's why we have to shift from spectrometer sensor to the SAR sensor. In SAR sensor, the resolution around about 5 to 10 meter and finer resolution wind field near to the coastal area. This is very important for economy point of view as well. So our main goal is that to analyze the wind field over the Gulf of Napoli. Well, what is the methodology we use to retrieve the wind field using the level 2 product from the Sentinel-1 satellite, which is launched by European Space Agency. And then we compare this result with well-known weather search forecasting model, because due to the lack of other sources like weather forecasting or some on-chip sensor, there is no availability of such kind of, so that's why we have to compare this one with well-known weather forecasting model. So, how can we estimate the wind? Because the wind field, we are using the C-mode family, C-mode IFR2 geophysical model function. This show a simple non-linear relationship between the normalized radar cross section with us wind speed and wind direction. In this, using this relation, we can estimate the wind field, but to get the information as to get the external information of wind direction from some external source. So we can get this information related to the wind direction from some spectrometer or some other models like ECMWF. Here, the brief discussion of weather forecasting model is that weather forecasting model is a numerical model that is used to serve both atmospheric research and operational forecasting needs. So, numerical weather predictions actually is to simulate and predict the atmospheric with computer models instead. So weather forecasting model has two dynamic courses like data assimilation systems and the software architecture for parallel computations and system accessibility. This model provides us a some wide range of the meteorological applications, like it's different resolution. We can get the wind field from different resolution from few meter to thousands of kilometers using this weather forecasting model. How can we analyze the data? How can we process the data? That we actually 2-year time series that goes from January 2019 to 2021. We collect the data over the Gulf of Napoli, that is a sea band Sentinel-1 VV imaginary, collected in interferometric wide mode. The size of each pixel is 1 by 1 square kilometer, and around about 370,000 total number of wind cells we are observing on that particular region of interest. Here are some results. As a showcase, we just show a SAR wind field and wind direction, in which we can see on the left side, just on on the left side, we can see the SAR wind field. Uh, we can observe that in this particular region, the the wind speed near to the coastal area is around about 5 meter per second, and when we move away from the coastal area, the wind speed is gradually increased, which is about 10 meter or 12 meter per second. Uh, while in the case of direction is around about 50 near to the coastal. These are the output of weather forecasting model, in which we can see that the same analysis and same pattern we can observe using the weather forecasting model near to the coastal area is around about 5 to 6 meter per second, and when we away from the coastal area, it's 10 to 12 meter per second. This show a very good agreement with SAR observation and the result predicted from weather forecasting model, the case of the wind direction as well. Here we can show the categorize of our wind field. Usually the wind field from less than 5 meter per second is considered as a low wind, and the wind field from 5 to 15 meter per second is considered as a moderate, and higher than 15 is considered as a high wind. So we can see that probability density functions, that this show that the most of the wind field in all over the examining period of 2 years, it's a whole time period, we can see that the wind field is blowing low to moderate, and they are very well agreement with model as well. In the case of direction, we can say that the most of the wind is blowing towards the northeastern direction throughout the examine period, and this show is also a good agreement between the ocean and forecasting model. There is another way to present our result, in which we can see that in the case of the SAR ocean, the most of the wind cell lies from 5 to 15 meter per second, and the eastern directed, which is very well good agreement with the weather forecasting model. This show another evidence to remarkably agreement between these results. Here we can see the root mean square error of weather forecasting, and the observation from the SAR. We can see that the most of root mean square error is less than 2 meter per second in all over the examined period, and in some places and even is less than 0.5 meter per second, which show a very good agreement between the observation we have made from the SAR data, and one is the predicted from the weather forecasting. While in the case of the direction, is the root mean square error is less than 30, which also show a good agreement with literature as well. Some statistical analysis we can see there. The average mean speed, wind speed for the SAR and the weather forecasting is around about 7 meter per second in all over the examined period, while the variability of wind speed in all over the examined period is 2.8 or 2.7 meter per second, regard of SAR observation and weather forecasting model. So this show and another show a good agreement for SAR observation and weather forecasting model. So, while in the case of the uh, variability of spatial variability, we can look the entropy map in which we can see the actually this entropy map show a 2-year SAR wind speed and wind direction in all over the examined period. And we can see that near to the coastal area, the more variability as compared to the open sea. This is a thing that near to the coastal area, there is lot of obstacles and lot of hurdles. So that's why the variation of the wind speed is more observing near to the coastal area as compared to the open sea. So while in the case of the wind direction, we can see the more variation, more variability in the case of the wind direction, which also show a good agreement to previously we have to predict it.
Just 1 minute.
Yeah, yeah. Okay. So that's when it's predicted from. So we can see the variation of the wind direction as well. In the end, here is the conclusion of my presentation that in this study, we see wind field analysis in near to the coastal area, the Gulf of Napoli. And for this, we are using the Sentinel-1 Level 2 product, which is definitely in regard of the space and time, which is well collocated with the weather forecasting model. And the resolution of the weather forecasting model is the same as from we take from SAR, it's 1 by 1 square kilometer. Primarily result based on the comparison of ocean and further forecasting model give a very remarkable agreement between these two one. And on average, we have to examine that, observe that the moderate wind intensity blowing and eastern direction wind is blowing through all the examined period. So in future we will see some using some other geophysical model functions, and we observe and we will see some other data and like local sensor. Then we have to verify our result more precisely. So that's the end of my presentation. Thank you very much for your attention. If you have a question or curiosity, then just write me. Thank you very much.